Right, in this brief video, we're going to discuss probability. So we can think of probability as the likelihood of the occurrence of an event or of the occurrence of an outcome or some combination of outcomes. So it's basically how likely the event is to occur or the events are to occur. Probability underlies pretty much all of the statistical hypothesis tests that are covered in a basic statistics course, so it's important that we at least have some background on probability because we'll repeatedly ask in this course what's the probability of our findings or the data or the difference between the means or the relationships between the variables. What's the probability of that given or assuming that the null hypothesis is true? So that's basically what a p-value is. It's the probability of your findings are more extreme assuming the null hypothesis is true. So if that p-value is low enough, we're able to have evidence against the null hypothesis and potentially reject the null hypothesis, whereas if the p-value is not low enough, we don't have enough evidence to reject the null hypothesis. There are various views of probability that we should touch upon now. One is the analytic or theoretical view, which uses equations to define the probability of an event. So something like as simple as if you flip a coin, what's the probability of it landing on heads, right? So that would be one of two possible outcomes. So that would result in a probability of 0.5. There's also the frequentist or empirical approach to determining probability. So this would be based on sampling or collecting data. So we wouldn't need to do this if we were flipping a coin, but if we wanted to, we could sit there and flip a coin, let's say, several hundred times and calculate the number of heads and number of tails, and we'd probably find something very close to 0.5 probability of heads and 0.5 probability of tails if we flip the coin enough, right? And there's also the subjective view of probability. This is more of a psychological view of probability based on one's belief in the likelihood of an event. This plays an important role in behavior and also to some extent in some forms of statistics which kind of are beyond the scope of this class, but it's important to keep in mind that subjective probability is a real thing. So when you let's say you go to the corner store and buy some scratch offs, the probability that you believe you will win is likely to be higher than the actual calculated probability based on the published information on the likelihood of you winning, let's say, $10,000 on the scratch off ticket. You probably, your gut feeling, your gut instinct, your intuition would tell you that you have a good chance before you scratch it off, but the probabilities are predetermined basically in terms of there's an equation, and that is likely. I mean, not likely. That is very quite unlikely. So it's important not to disregard subjective probability, at least from a psychological perspective. So probability ranges from 0 to 1. It's usually reported in decimal form. 0 would mean the event has no probability of occurring. So something like, what's the probability of when the sun comes up tomorrow, it has that Teletubby baby's face on it, right? That's probably a 0. That's not going to happen. It has no chance of occurring. Whereas a probability of 1 means the event is guaranteed to occur. So something like, what's the probability that the sun will come up tomorrow, right? So it's probably pretty close to 1. Those are not interesting things that are never going to occur and things that are guaranteed to occur. So in terms of probability, we're usually talking about a decimal. So like 0.75 probability means that it would take place 75% of outcomes would result in that particular event. So before we wrap this brief lecture up, let's go over some basic terms. An event, as we've already noted, is a possible outcome. A set, or I should say, a universal set, is a collection of all the events or all the outcomes. Many calculations in probability assume that the outcomes are independent. So, what that means is that one event has no effect on the probability of another. And people can get confused and commit fallacies when they don't realize that events are independent. So, for example, if we tossed a fair coin and we got heads 4 times in a row, what's the probability that the fifth time it would land on heads? Now, some people would actually say that that's less than zero point 0.5, but the probability for each individual independent toss is zero point 0.5. The previous tosses have no impact on what happens subsequently. This is related to the gambler's fallacy, which is basically the erroneous belief that if an event has occurred um, frequently previously, it's unlikely to occur subsequently. So, for independent events, that would be an erroneous belief or a fallacy. Mutually exclusive events means that there's not event overlap. So if one event occurs, the other cannot. So if the coin is tossed and it lands on heads, then it cannot land on tails. So both outcomes are not possible in one event. Uh, a lot of probability calculations also assume that we have an exhaustive list of all possible outcomes, that is the universal set, and that the sum of the probabilities for each event should then therefore add up to 1. All right, so I hope you've enjoyed that brief lecture over some basic terms and concepts related to probability, and I hope you have a good day.